from nest 2008. A proton moves in the z direction after being accelerated from rest through a potential difference capital V. It then passes through a region with uniform electric field E in the positive x direction and a uniform magnetic field B in the positive y direction, but the proton's trajectory is not affected. If the experiment is repeated using a potential difference of 2V, the proton will be deflected in negative x, positive y, negative y. Okay, fine. So we have proton in the z direction. Okay, what's the formula? Half mv squared is equal to ev. Let's say that the charge on the proton is e with the sign positive. Okay, ev. Right, so what will be the speed? Under root 2 ev by m. Is this part clear? Kinetic energy final is equal to the potential energy initial. Clear?
Yes, sir.
Okay. Now there is a topic called velocity selector. Yes.
Sir, is the negative x correct?
I don't remember.
Okay.
Okay. If it then passes through a region with uniform electric field E in the positive x direction, so we can take E bar as EI cap, and uniform magnetic field B in the y direction, so we can take B bar as BJ cap. Trajectory is not affected. Now trajectory is not affected means net force acting on it is 0. Right? Net force acting on it is 0. Alright. So which force is 0 now?
Lorentz force.
Exactly, EEI cap plus Q V bar, which is VK cap, cross BJ cap is equal to 0. Well, we know now that E will be equal to V bar in that case. Okay. K cross J is negative I, so E is equal to Vp. We know that. Okay. Now here is my take on this. Let's write this EEI cap plus, let's consider the third possibility now, or third case, not case, third step we can say, where the proton's speed is no longer the same, okay, because it is accelerated through a higher potential. Got it? So what can I do? What can we do rather? Look, do you agree that the new speed would be root 2 times the old speed? Because V is getting replaced by 2V. So the new speed before it enters the region will be root 2 times V. Do you agree to that? Please raise your hands. Initially V, finally 2V. Yes, okay. So this is what I will now be doing. E root 2VB with negative I. Okay. This is the net force now. And mind you, it's not equal to 0. Okay, it is not equal to 0. Okay. Now look, EE is actually equal to VB, right? EE is actually equal to VB into that. So what I can say is EVB I cap minus E root 2 VB I cap. Right? That's the net force in this case. Okay? Net force in this case. Because that initial one was already balanced. Right? Initially it was already balanced. And now it boils down to the fact that F net will be root 2 minus 1, it's positive quantity, EVB with negative I cap. So if you have a force in the negative I direction, obviously the deflection will also take place in the negative I direction. So Shashwat's answer is right. Did you make the same steps or you had some other approach?
Sir, by when it said that the trajectory remains the same, I understood acceleration is zero, which means force is zero. And if the voltage increases, the electric field would increase in the opposite direction.
How electric field is not increasing, electric field is constant.
Yes, this is the total force because like I use the potential gradient formula.
No, but this is not changing. These two are not changing either in magnitude or in direction, right?
So, but wouldn't doubling the
You are
potential
doubling.
difference also cause a change in the electric field?
No. The agency that is creating the potential difference may not be the same as the one that is creating field. Got it?
All right, sir.
So potential difference 2V doesn't make electric field 2V. If that's what you thought, then that's not right. Correct?
Yes, sir.
So this then is important. So first you are accelerating and then you are letting it go in that region. Okay. So has everybody understood this?
So could you explain the last step again? Like how did you get minus I?
Okay, good. Do you agree that this is the field that this is net force that the charge experiences?
Yes.
With root 2 being the new velocity root 2v. Now from the
Yes.
first case we already know that E equals Vb. Which V equals, which V is this? This is before it is accelerated through 2V. This is V only, I mean this potential difference. Got it?
Right.
So I just put that E as Vb. Clear?
Clear.
But then you know that in the second thing we've got, you are subtracting negative, let's say you are subtracting root 2 from that. So if you write it root 2 minus 1, that negative sign is bound to come there because root 2 minus 1 is positive. Proton's charge is positive, speed
Okay.
is positive, B is there.
Right.
So if you have a net force acting in that direction, obviously it would accelerate in that direction. Or deflect. Okay? Clear? Yeah. So any guesses what would the trajectory be? Any guesses what would the trajectory be? Yes.
हेलिकल सर.
हेलिकल कैसे होगा? जे तो कंपोनेंट है ही नहीं ना उसमें.
सॉरी.
प्लेनर ही है ना. Okay, let's write down V bar. Okay, and then that would be root 2V k cap. Yes, please tell me what would the trajectory be now if you.
Sir, integrate this velocity.
Of course, I'm going to integrate it. Yes. Do you think it will be parabolic? Do you think the trajectory will be parabolic? Yes, no.
Yes, sir. Quadratic
This looks
equation.
like parabola.
Yes, and we have already solved this problem somewhere else. Imagine that diver situation, ski diver. His initial velocity of projection was in this direction and the gravity was acting downwards. Something similar is happening here, right? The only difference is there the diver didn't have any vertical component of velocity. Here he has. Oh, even here it isn't. Okay, like t0 is 0. Yeah, correct. So the trajectory would be parabolic. Have you understood that?
Yes, sir.
Yes, sir.
Okay.